Man has cultivated sugarcane since antiquity and processed it into crystals since 500 BC. Some of the highest quality sugar came from Hawaii. But how is sugar made? Let's follow the entire process. Once the island chain's largest sugar plantation, some 36,000 acres, was the Hawaiian Commercial and Sugar Company at Pu'unene on Maui. We'll follow the process from harvesting the raw cane right through the sugar mill. Sugarcane varieties grown in Hawaii took about 2 years to mature, so planting was staggered, and about half the plantation's fields were harvested annually. The sugar being harvested has already been manufactured, so to speak, right inside the plant during the growing process. Microscopic root hairs take up water from the soil. The water, made up of hydrogen and oxygen, is pulled up into the leaves. Meanwhile, small openings in the leaves are filled with air, which contains carbon dioxide. Light from the sun is absorbed by chlorophyll in the leaves. Sunlight provides energy to combine hydrogen, oxygen, and carbon dioxide in the natural process called photosynthesis. This forms sucrose, the technical word for sugar. Sugar is stored by nature in the stalks of sugarcane. Now it's a matter of taking that sugar out and putting it in a form we can use. Once the cane has reached maturity, it's ready to be harvested. The normally intensive irrigation was halted, causing the cane to store more sugar in the stalks and drying out the cane leaves. Then the fields were ignited. This dried material was quickly burned away, but the sugar-laden stalks, about 2/3 water, were not harmed by the fire and were left ready for harvesting. A large bulldozer, called a push rake, harvested the cane mechanically. The cut stalks were piled into long windrows, which made loading them aboard the cane haulers more efficient. Up to 4 tons of cane were grabbed by the hydraulic crane and dropped into the cane hauler, which could hold an enormous 64 tons of cane. That's about the same weight as 8 full-grown African elephants. The hauler transported it from the fields directly to the sugar mill. As these massive cane haulers reached the mill, they pulled up in turn to a large crane. Under the crane, each trailer had a bed of chains, one side of which was attached to a long bar called a strongback that rested along the trailer's top edge. By hooking onto this bar, the crane was able to lift the entire load up and out of the trailer at once and dump it onto a conveyor belt bound for the inside of the sugar factory. As the cane initially entered the mill, it went to the cleaning plant, where it was washed to remove rocks and other debris. We cannot see the next 2 steps because the machinery is enclosed, but whirling blades sliced long stalks of cane into short pieces, and these were then pulverized into juice-filled fiber particles by a hammer mill, simply called the shredder. The shredded particles then went through roller mills that extracted the sugar-laden juice. These were a series of 4 mills, each with 6 rollers. The first mill extracted about 70% of the sugar, while the others continued the process. At the 4th and final mill, hot water was sprayed on the cane fiber to aid in removing as much sugar as possible. About 95% of the sugar was extracted. Meanwhile, the juice containing the sugar passed through a perforated revolving drum that filtered out any remaining cane fibers. The filtered juice was then collected in a holding tank from which it was pumped to the boiling house. In the boiling house, the juice was heated and kept hot for the duration of the sugar processing. The heat forced dissolved air out of the juice. It also helped coagulate any residual debris before it went to the clarifying tank, where suspended particles settled out. The clarified juice goes through a series of evaporators. This process thickened the juice into a syrup. In the first evaporator, live steam from the factory boiler was used, while in each succeeding step, the vacuum pressure was increased to lower the boiling point. By the final step, the vacuum pressure was so high, that it allowed the syrup to boil at less than 150 degrees instead of the normal 212. Syrup from the evaporators was pumped to a supply line around the outside of the continuous vacuum pan. Automatic syrup feeders with pneumatic valves added syrup in regulated amounts as needed. Sugar was crystallized out of this syrup, which became a mixture of molasses and sugar crystals known as mascuite. Sight glasses allowed monitoring of the boiling process. The mascuite was batch-fed into centrifugals to separate the molasses from the sugar. During the high-speed rotation of these perforated cylinders, steam washed molasses off the sugar crystals, and the molasses was then spun off through tiny holes in the walls. The molasses was pumped to large tanks to await transport to the harbor. The raw sugar crystals were mechanically scraped off the drum and dropped onto a conveyor belt, which took them up to a bulk sugar room at the end of the factory's main processing line. From there, wool haulers from the field lined up to begin the process anew. Bulk sugar transporters took the raw sugar to Kahului Harbor for shipment to the California and Hawaiian Sugar Refinery in California. There, it was refined into the familiar white, brown, and confectioner's sugars, which were marketed under the C&H label. After more than a century of operation, the Hawaiian Commercial and Sugar Company Plantation and Mill closed in December 2016.